We're going to perform a short experiment to determine the acceleration due to free fall. And in order to do that, we're going to use a few things. We're going to use what's called a smart timer because we know that human reaction time isn't great. So this smart timer is attached to a system where we have a ball inside a clamp here, and as soon as I release that clamp, the timer starts, and as soon as the ball hits the plate here, the timer stops. And we'll do this a number of times. So the first thing we need to do is measure the distance that the ball is going to fall. So using a meter stick, I measure it as 77.3 centimeters. But remember that this is a measurement, so I need to use measurement notation. So I think I'm good to the nearest millimeter, 77.3 plus or minus 0.1 centimeters. But I will need to convert that to meters right away. So I may as well do the conversion right away. Is 0.773 plus or minus 0.001 meters. So that's the height that the ball will be falling each time. The other thing I need to collect is some information about how long this takes. And even though this is a very precise timer, I think I also want to take a multiple measurements and then take an average to improve the precision of this. So let's do 5 trials, 1, 2, 3, 4, 5, and then we'll take an average of that. Okay, we'll take an average of that. And so now I've set up a table, and it looks like this, right? And it describes our experiment. So if we think about our experiment, it's quite straightforward. We have 2 events. The ball is released, the ball strikes the pad, makes initial contact. Delta Y12 I just measured, 77.3 plus or minus 0.1 centimeter. And then I said I'm going to do 5 trials. I'm going to collect 5 pieces of data for delta T12. I'll put my units in there. They should be in seconds. And then at the end I can use this equation, which is one of my big 5, to determine what acceleration is. Because I know the initial velocity is 0. I know that the distance the ball falls, and I'm going to have the time. So between those things I should have no problem determining what the acceleration due to gravity is. So let's begin. And sometimes this thing kind of misfires, so I may need to do some measurements and go, yeah, that's not a good one. I know roughly where it should be. So now I'm going to begin. There, the ball's in. 0.3987, let's write that one out. That's going to be seconds. 0.3987. Don't worry, I'll show you this again. And there's the data we've collected. Write that down.